Far beyond Earth lies a region where sunlight is no longer a familiar presence. The solar system begins to fade, the influence of the sun weakens, and the darkness between stars becomes real. Yet in that distant frontier, one human-made object continues to operate against every expectation. That object is Voyager 1. It was never built for this journey. Its mission was simple: visit the giant planets, collect data for a few years, and eventually fall silent. Instead, it traveled farther than anyone imagined, passing Jupiter, Saturn, and eventually leaving the Sun's protective boundary behind. Now it moves through interstellar space, carrying instruments that continue to observe an environment humanity had never directly explored before. Voyager 1 launched in September 1977 during a rare planetary alignment that happens only once in many generations. This alignment allowed spacecraft to use the gravity of giant planets as natural accelerators, gaining speed and reaching farther destinations while saving fuel. NASA took advantage of that opportunity and launched Voyager 1 and Voyager 2. Even in its early days, Voyager 1 was already changing expectations. Soon after launch, it captured an image showing Earth and the Moon together from deep space, offering humanity a completely new perspective of home. But its greatest discoveries were still ahead. At Jupiter in 1979, Voyager revealed extraordinary details of the giant planet. It confirmed the immense scale of the Great Red Spot, discovered Jupiter's faint ring system, and identified previously unknown moons. Its most astonishing discovery came from Io. Scientists witnessed active volcanic eruptions beyond Earth for the first time. Entire plumes of material were seen rising from the Moon's surface, proving that distant worlds could still be geologically alive. Then came Europa. Its cracked icy landscape hinted at something hidden beneath the surface. That observation helped inspire the idea that a liquid ocean might exist below the ice, raising the possibility that environments suitable for life could exist elsewhere in the solar system. Voyager was no longer simply exploring planets. It was expanding humanity's understanding of where life might exist. At Saturn, the mission continued to transform science. The spacecraft revealed the incredible complexity of Saturn's rings, showing thousands of fine structures rather than simple bands. It also transformed Titan from a mysterious orange object into one of the most fascinating worlds known. Titan possessed a thick atmosphere and an unusual chemistry where methane behaves in ways similar to Earth's water cycle. Clouds, rainfall, and lakes existed there, not of water, but methane. To study Titan more closely, mission planners changed Voyager 1's path permanently, sending it out of the plane of the solar system and toward interstellar space. That decision altered history. For years, scientists expected the outer boundary of the Sun's influence to be gradual and diffuse. The Sun continuously emits charged particles known as solar wind, creating a vast protective region called the heliosphere. Beyond it lies interstellar space. Most models predicted a slow transition. Voyager found something different. In August 2012, changes appeared suddenly. Solar particles dropped sharply. Cosmic rays increased. The surrounding environment shifted dramatically. Instead of a smooth transition, Voyager crossed what felt like a distinct boundary. Humanity's first object had entered interstellar space. And what it found was surprising. The interstellar magnetic environment proved stronger than expected, pressing against the heliosphere more intensely than many models predicted. The galaxy beyond the solar system was not empty. It was structured, active, and exerting pressure back against the Sun's domain. Yet perhaps Voyager's strangest discovery came years later. Between 2017 and 2020, instruments detected a persistent low-frequency signal around 3 kHz. This was not ordinary sound. It was a plasma oscillation, electromagnetic activity moving through. The signal remained steady, faint, continuous. Its importance was enormous because it allowed scientists to directly measure the density of interstellar plasma. For the first time, humanity was not studying the medium between stars only through theory. It was observing it from within. Voyager had become an instrument listening to the electrical structure of interstellar space itself. This revealed something profound. The region between stars is not empty silence. It contains magnetic fields, particles, remnants of ancient stellar events, and the lingering structure of our galactic neighborhood. The signal Voyager detected was not a message. It was the natural resonance of the environment surrounding our solar system. And somehow, the spacecraft is still functioning. Voyager 1 uses technology designed in the 1970s. Its systems were never intended to survive for decades. Yet more than 24 billion kilometers from Earth, it continues sending signals back using power comparable to a small household light source. Those transmissions arrive incredibly weak. Still, Earth can hear them. Keeping Voyager alive has required constant sacrifices. Instruments have gradually been shut down to preserve energy. Then in late 2023, another challenge appeared. Voyager began transmitting corrupted information caused by problems in its memory system. Repairing a spacecraft at that distance seemed almost impossible. Commands required over 22 hours to arrive. Responses needed the same amount of time to return. A single exchange took nearly 2 days. NASA engineers adapted old software, redirected functions around damaged memory areas, and transmitted repairs across billions of kilometers. Eventually Voyager answered correctly again. The spacecraft survived. Because of that recovery, it continued operating in interstellar space. Voyager also carries something symbolic. Attached to its exterior is the golden record. Inside are sounds, music, greetings, images, and fragments of human life. Rain. Ocean waves. Thunder. Voices. Music. Small pieces of Earth preserved for a journey that may last millions of years. The record was never created because humanity expected an immediate discovery. It existed because if something from Earth was leaving forever, it should carry evidence that we were here. Voyager became more than a probe. It became a messenger. It revealed volcanic worlds, hidden oceans, complex atmospheres, the edge of the heliosphere, and the structure of interstellar space. It crossed the boundary between the Sun's influence and the galaxy beyond. And it kept reporting back. One day Voyager 1 will finally fall silent. Its power will fade. Its instruments will stop. Its transmissions will end. But the spacecraft itself will continue onward. Still carrying the golden record. Still moving through interstellar space. Still traveling deeper into the galaxy long after humanity no longer hears its voice. And perhaps that is what makes Voyager extraordinary. It was built for a short mission. Instead, it became humanity's first long-distance witness to the stars. Even now, Voyager 1 continues moving farther from Earth at incredible speed, increasing the distance between itself and humanity every second. It no longer travels toward planets or destinations. Its journey has become something different, a passage into regions that no human-made object had ever explored before. At its current distance, communication itself feels almost unreal. Signals sent from Earth require more than 22 hours to reach the spacecraft. The reply takes just as long to return. Nothing happens quickly anymore. Every instruction is delayed by nearly a full day. Every answer arrives from a machine operating billions of kilometers away in darkness where sunlight is only a faint memory. Yet Voyager still responds. That alone is extraordinary. The spacecraft survives using radioisotope power generated from decaying plutonium. But that energy source is slowly weakening year after year. Because of this decline, engineers continue making difficult choices. Systems are turned off. Heaters are disabled. Scientific instruments are sacrificed. Each shutdown buys a little more time. A few more months. Perhaps another year. The mission has become a balance between survival and discovery. Every remaining watt matters. And still, Voyager keeps listening. The region around it is unlike anything within the solar system. The sun